Hello guys, welcome to this lesson. So in this lesson we want to look at trigonometry. Okay. So at the end of this lesson you should be able to recognize trigonometric ratio, trigonometric function and how to use them. So we'll be looking at angles and and degree measure. So we'll first look at angles and degree measure. Okay. So we'll also look at another aspect which is converting between decimals, converting between degree, minute and second. Okay, degrees, minutes and seconds. We'll look at radians, converting between radian and degrees. Okay, and we'll look at many other things as the lesson goes by. So let us start with these three objectives. So at the end of this first lesson, you should be able to find angles. You should be able to describe how to use degree to measure angles. You should be able to convert degrees minute to convert between degree, minute and second. And you should be able to convert degree to radian and radian to degrees. So let's start from the first lesson. So and again, when we talk about trigonometry, so trigonometry basically means angle measure. Okay, trigonometry, it comes from the word trigono. Okay, which means when we talk about triangle, okay, or tri, so three, call it tri. Okay, and trigono has to do with triangle basically. So yeah, that's to do with triangles. And then when you say metry, that is measurement. Okay, measurement. So we can basically describe it as the measure of angles in a triangle. Okay, alpha, beta, or gamma. And of course, we know that sum of angle in a triangle is equal to what? 180 degree, right? So angles are formed when two lines meet. So the vertex between two lines forms what is known as angles. So trigonometry is a measure of angles in a triangle or other shapes. So let's look at our first lesson, angles and their measures. So first of all, you know that a ray or a half line is a portion of a line that starts at a point, okay, and end at a particular point also. So when two rays of line meet, we have an angle. Okay, so this place forms angles, and you have angle theta. So if this place is let's say this is P and this is point Q, this is R. So this angle theta or theta equals to angle PQR. Okay, or you can write it as PQR. You put the angle symbol on the letter. So we can use this symbol or uh, this symbol to denote angle measure. Okay, or angle symbol. Let's call it angle symbol. So an angle is formed when two rays of line meet at a terminal point. Okay, so we have types of angle. Of course, these are very elementary that you've learned in junior school. So we have types of angle. We have acute angle. Acute angle is greater than 0 and less than 90 degrees. So the angles between 0 and 90 degrees are said to be acute. Okay, and then when you draw them, they normally terminate at a point not up to 90. So the description is theta greater than 0 and less than 90 degrees. Then we have right angle. Right angle is an angle that is exactly equal to 90 degrees. And then whenever you see this square symbol in any sign, in triangle or any shape, it means a right angle. Okay, so when you are measuring angle is normally measured anti-clockwise. Okay, so we measure angle anti-clockwise. Measure positive angles anti-clockwise. Okay, so we are still going to discuss that when we get to subtopic. But when you want to measure positive angle, you should measure backward, measure anti-clockwise. Then we have obtuse angle. Obtuse angle are angles between 90 degree and 180 degree. So they are strictly greater than 90 and strictly less than 180 degree. So obtuse angle can be described as angles from 91 to 179 degree. Okay, and then we have straight angle. Straight angles is an angle that add up to 180 degree, or an angle that is exactly equal to 180 degrees. So we also call it angle on a straight line. Okay, angle on a straight line. Then there's another type of angle which is not mentioned here. We have what is called angle at a point. Okay, angle at a point. Do you remember what angle at a point is? Yeah, angle at a point is always equals to 360 degree, and that can be described as angle in a circle. Okay, so when you have a lot of points, let's say this is uh, a, B, C, D. So A plus B plus C plus D equals to 360 degree. So that is angles at a point. Okay, alright guys, so complementary angles. Complementary angles are angles that add up to 90 degree. Okay, when two angles or more add up to 90 degree, they are said to be what? They are said to be complementary. So in this diagram, we have alpha, where the angle is 90 degree, but it is being divided into two, alpha and beta. So if you add them up, alpha plus beta will be equal to 90 degree. So it then implies that alpha equals to 90 degree minus beta, and beta equals to 90 degree minus alpha. Okay, so complementary angles add up to 90 degrees. So let's look at this example briefly. Example 1. Or if you see from the diagram, these angles are complementary, so we simply add them up. So therefore 5x plus 5 plus 3x plus 5 must be equal to 90 degree. Okay, so 5x, if we collect like 10, 5x plus 3x plus 5 plus 5 must be equal to 90 degree. So 8x plus 10 must be equal to 90 degree. So 8x equals to 90 degrees minus 10 degree. So 8x equals to 80 degree. Okay, so if we divide both sides by 8, you can see that 8 will cancel 8, and here we have 1. So we have x equals to 10 degree. Okay, and then we can find the measure of the size of the angles. So the size of the first one, so 5x plus 5 will be equals to 50 plus 5, which is 55 degree, and 3x plus 5 will be equals to 30 plus 5, which is equals to 35 degree. And then if you add both of them up, you see that it will be equals to 90 degrees. So they are complementary. Example 2. Find the value of x for a supplementary angle. Okay, so let's quickly do a cross check. Good. Supplementary angles. Two angles are said to be supplementary if they add up to 180 degree. Okay, two angles are what? Supplementary if they add up to 180 degree. That is, here we have alpha plus beta equals to 180 degree. So it then implies that alpha will be equals to 180 degree minus beta, and then beta will be equals to 180 degree minus alpha. So that is what it symbolized, and that is what it means. Example: find the value of x for supplementary angles with measures 10x plus 7 and 7x plus 3. So basically, we are going to add them together. So 10x plus 7 plus 7x plus 3 will be equal to 180 degrees since they are supplementary. So if we collect the like term, we have 17x plus 10 equals to 180 degree, and that will be 17x equals to 180 degree minus 10 degree. So 17x equals to 170 degree. We divide both sides by 17. So 17 cancels 17, and 17 here 1. So that basically we have x equals to 10 degree. So if we check by substituting the value, we have 10x plus 7 will be equal to 100 plus 7, which is 107 degree, and then 7x plus 3, that will be 70 plus 3, which is 73 degree. If you add two of them up, they will be equal to 180 degrees, so it is correct. Hope you are following along with the lesson and getting what we are trying to explain. So this is how to find complementary and supplementary angle. So quick one, let's go to degree measures. So when we talk about degree, that is the unit that is that at an angle that all angles are measured in. So the angle formed by rotating the initial side, okay, or exactly once in the counterclockwise direction until it coincides with itself is one revolution, and is said to be 360 degree, abbreviated as 360 degree. So 1 degree is 1 over 360 revolution. You know, this is what we are saying. You know that angle in a circle is 360, right? Good. So angle in a circle is 360 degree. So this is where the definition of degrees come from. So one revolution, that is one cycle. So if you should have understood this in from physics, if I'm not mistaken, one cycle equal to 360 degree. Okay. So to find the degree, if we divide both sides by 360, so we'll have that 360 here equals to 1. So 1 degree will be equals to 1 all over 360 cycle. So this is the formula for degree, and this is the initial definition of degree. Degree is used for to measure angle, and the definition is derived from a circle. Okay, circular revolution. So that is why the total angle in a circle is 360 degree, and then we can see the analysis in this diagram. So remember, angles degree are normally measured or counterclockwise. So counterclockwise, so we have the division here is 0. The starting point is always 0 degree, which is the positive x-axis, and then you rotate counterclockwise towards the y-axis. So it starts from 0 degree up to 45, up to 90, and then up to 180, up to 270, and 360. And that is the four division that we have in a circle. In a circle, we have four division, which is also known as four quadrants. Okay, and then we have angles in each axis. The angle of the axis is 0 degree, 90 degree, 180 degree, 270 degree, and 360 degree. So you start from 0 and then you end at that same 0, but when you end there, it becomes 360 degree. So if we divide it into 4, we'll have four sets of 90 degree angle. And then we have the first quadrant, we have the second quadrant, we have the third quadrant, we have the fourth quadrant. In the first quadrant, the angles in the first quadrant are acute angles. Okay, so they are acute. Okay, in the second quadrant, the angle we have here are obtuse. Okay, and in the third quadrant, the angle in the second quadrant are between 90 and 180, and the angle in the third quadrant are between 180 and 270. The angle in the fourth quadrant are between 270 and 360. Okay, and then you go back there. So third and fourth quadrant are called reflex angle because they are greater than 180 and less than 360. Okay, so this is how we measure angle. Okay, and then based on this circular unit, you can draw angles using protractor. You know, the protractor we normally have in mathematical set are half, which is 180 degree, but we have some math set now that have complete one, complete 360 degree one. So that we use the definition derived from the circular measure of angle to define angle, and then we use it to draw angles and to measure angles. Okay, so